Hello friends, today we are going to see normal distribution. We are thankful to Professor David Lane who allowed us to use this course resources. Introduction to normal distribution. Normal distribution is the most important distribution in this statistic. Why? There are two reasons. First, most of the natural phenomena follows normal distribution, and second, most of the distributions, when n becomes very large, it becomes normal or it follows approximately normal distribution. That is why this is the most widely used distribution in the statistics. It is named as normal curve, normal distribution. Its shape is like bell, that is why it is also known as bell shape, or it was found by Gaussian, developed by Gaussian, that is why it is also known as Gaussian distribution or Gaussian curve. There are varieties of normal distribution. Means for each variable, if you draw its histogram and draw a freehand curve, then you will find different shapes. All shapes are approximately bell shape or like normal shape, but they are different. So we can say that as many variables are there, that much normal distribution can be found. But why it is so? Because every variable has different mean and different standard deviation. And that is why there the shape of that normal distribution of that variable will be different. So here we see a normal distribution for three variables. Okay. In the first, the mean is less, or we can say that mean is different for all the distributions, and similarly the variance. Now, but though there is a difference, there is some similarity in it also. So, what is this similarity? That this distribution are symmetric distribution, or we can say that characteristics of normal distribution, that it is a symmetric distribution, that is it is, it has same shape from the middle. It is a distribution for continuous variable, that is for like Poisson and binomial is a distribution for discrete variable, while normal is a distribution for continuous variable. In case of normal distribution, mean, median and mode are equal. That is, mean is equal to median is equal to mode. The total area under the normal curve is 1, and normal distributions are denser in the center, and as we go outer side it getting thinner, and towards tail it becomes very thin. But the two tail of normal distribution never touches the baseline. That is why the area or range of this distribution, it ranges from minus infinity to plus infinity. Normal distribution are defined by its two parameters. One is location parameter mu, that is mean. Mean is the location parameter, and standard deviation is the scale parameter. So if we know the mean and standard deviation of any distribution of any variable, then we can find the distribution, normal distribution for that variable. Now, these are the same features which we have talked. Here, this is a graph of normal distribution. From the middle line, here, it is symmetric on both the sides. Okay, so total area under this curve is 1. As it is symmetric, the left hand side value is 0.5 and right hand side value is also 0.5. Now, if we take, this is mu, mean, median or mode. If we take mu plus or minus 1 sigma, it contains 68.27% of the observation. That is, mu plus or minus 1 sigma contains 68.27% of the observation of the given distribution if it follows normal. Similarly, if we take mu plus or minus 2 sigma, it contains 95.45% of the distribution. And if we contain mu plus or minus 3 sigma, it contains almost 99.73% of the observation within this limit. Okay, that is why the normal distribution is very important, because if we take mu plus or minus 3 sigma, then it contains 99.73% of the observation. As you are aware of 6 sigma, okay, they are considering mu plus or minus 6 sigma on both the sides. That means the possibility that any unit or item is defective is very very less, and if then also it is defective, then there must be some problem in the system or process, and that is to be checked and repaired. This is the main logic behind Six Sigma. So Six Sigma or quality control is also based on normal distribution. A history of normal distribution. If a fair coin is tossed for 100 times, what is the probability of getting 60 or more heads? If we have to calculate this probability, then using binomial distribution, we know that PDF of binomial distribution is NCX p raised to x q raised to n minus x, where x is equal to 0, 1, 2, 3. Now here we want to find 60 or more heads, 60 or more. That means we need to calculate P60 plus P61 plus P62 up to P100. And by adding all this, we'll get the required formula. But this is, as we can see, very tedious job. So Abraham D. Morvay, Abraham D. Morvay, who was a consultant to Gambler, he noticed that the as the number of events increase, the distribution approaches to normal or a smooth curve. Now we'll see this using an example. Suppose if we toss a two coins, then probability of zero hit. There are four outcomes: HH, HT, TH, and TT. Suppose we say zero head, that is both T, TT. There are one out of four. One case is TT. One head, that is HT and TT. Two case of one head, and HH, that is one case of HH, two heads. So this is the distribution of n is equal to 2, tossing a 2 coin. Here we can also see if we toss a 1 coin, then if we toss a 2 coins, probability of getting 0 head, that is 2 tail, is 1 by 4, and 2 head is also 1 by 4. Now suppose if we increase from 2 to 4, if we toss 4 coins, then there are 5 possibilities. We can have all the tails or all the heads. That is, all the tails means 0 head, 1 head, 2 head, 3 head, and all heads, 4 heads. We can see the probability for each value is given. Now, if we increase this, suppose from n to 12, 4 to 12, then we can see that this distribution, which increase in n, binomial becomes normal, or binomial follows normal distribution. So, what is the importance of this normal curve? Because as I told you, many natural phenomena are follows approximately normal distribution. Galileo in 17th century noted that the error were symmetric and that the small error occurred more frequently than the large errors. When he was studying the astronomy, he was studying the astrology, he found that there are some errors in calculation, but the frequency of small errors are much higher than, than frequency of large error, or large error occurs very less. The same thing independently uh, observed by Gauss and Adrien, independently by both these mathematicians in 1909 and 1908. And they also said that normal distribution are very good for good fit where errors, we are studying the errors. Quetelet was also the first to apply normal distribution to human characteristics such as height, weight, and strength were normally distributed. So, what do you mean by normally distributed? Suppose we take a class of 100 students, and if we take their weight, let us say if we take their weight, then what is the average weight? That is mu. What is the standard deviation? That is sigma. Now, if we take mu plus or minus 3 sigma, that becomes a range. That is mu minus 3 sigma to mu plus 3 sigma. There is a chance that almost all all data points lies within this range. All data points lies within this range. Then this is called a normal distribution. If now central limit theorem, Laplace discovered the same distribution in 1778 and he named it as central limit theorem. Even if the distribution is not normally distributed, the mean repeated sample, the means of repeated sample from the distribution would be very nearly normal, and that is the larger the sample size, closer the distribution to be a normal distribution. That is, the distribution of sample mean is approximately normal. Now, what does this mean? Suppose we have a class of 100 students having a very variety of heights. Okay, then very tall students and very short uh, students are there. Now, suppose if we know that this distribution are not normally distributed. Why? Because so many points are outside our mu plus or minus 3 sigma. So if the distribution is like this or any other which is not normal, then if we take, suppose we take out of 100 students, we take a sample of 5 students and we take 10 such samples or 20 such samples randomly, okay, and find the mean height of each sample. And if we draw the curve of this sample mean, then this distribution of sample mean is not approximately normally distributed. Again, keep in mind that original data or population was not normal. But if we take, instead of taking simple units, if we take a mean of sample, then its distribution is approximately normally distributed. This was this is the central limit theorem, which is a very important in statistics. Now, area under normal curve. This can be found in two ways. Okay, it can be computed by calculus, or there are some ready computer programs are also available, and we can also find it using the table under normal curve. We are going to see using both this, that is tables and computer programs. Now suppose area under normal distribution. Suppose the normal here is the normal distribution with mean 50 and standard deviation 10. So this is a normal curve. Keep in mind this two line doesn't touch to the baseline. Now mean is 50, so we have to put mean 50 in the middle. It is highest mu plus or minus 1 sigma, that is 50 minus 140, 50 plus 160. So this range, consider the black part consists 68.27% of the observation of the distribution having mean 50 and standard deviation 10. Now suppose instead of 1 SD, if we take 2 SD, then it contains 95.45% of the observation. But if we want to find exact 95% observations, then we have to take mu plus or minus 1.96 sigma. So it contains exactly 95% observation within this range. Now, how to find the area for given x? Now, suppose this is a given distribution and we want to find what is the area or the probability that value of x is greater than 110, more than 110. So here please keep in mind two three things. Okay, so in middle it is a mean, on the right hand side it is a plus value. Okay, so here uh, we have to find the value or area for x greater than 110. So we have to put the mean, the SD, and this value in the computer program. It will directly give us the area 0.04779. So many normal calculators are available online and we can find it. Now, the reverse. If we want to find, if mean is 70, mean is 90, and SD is 12, now how many of, or what are the cutoff marks for 75% of the observations? Suppose we can consider like this. If uh, in the JEE exam they want to find the cutoff mark, okay, and they keep, so these are the marks of the students, okay, and they know what is the average marks, what is the standard deviation of the mark. Okay, and if they want to find the area of 80%, so if you put area is equal to 0.80 here, they will give you the max. That is, if you keep your cutoff 98, okay, then top 20% of the students are eligible for the, let us say, advanced JEE. So there we find two things. From the value we find area, and second, here in the previous slide, what we have done, for 110 what will be the area, okay, and in this slide, if we want area of 0.75 or 0.80, what will be the cutoff mark. So these two things we can find using normal calculator. We can also find this using table also. But as we see that for every different mean and different SD, we have this value on the baseline will be changed, as well as this shape of the normal distribution is also varies slightly. So these distributions are, so it becomes difficult to calculate the values for different distributions, and that is why the idea of standard normal distribution kicked in. That means, what is standard normal distribution? So a normal distribution with mean 0 and standard deviation 1 is called standard normal distribution. So the idea is, for any given distribution, we subtract each value from its mean and divide by standard deviation. So we standardize the values, and this process is called standardizing the distribution. That is, a value from any normal distribution can be transformed into corresponding value of standard normal distribution using z is equal to x minus mu upon sigma. This is how we can calculate different values of z. What is z? Z is the standard normal distribution. X is the value of normal distribution. Sorry, value of original distribution. Mu is the mean of original distribution, and sigma is the standard deviation of original distribution. Now, what proportion of normal distribution with mean 50 and standard deviation 10 is below 26? Now, here we want to find, see, up till now we were writing 50 standard deviation and 10 SD, and from the table or from the using that formula, or uh, using calculator, online calculators, we calculate area. But now, here, now we are going to use the table. So first thing is to convert any value into z. So what is z? Z is x minus mu upon sigma. For this distribution, mu is 50, SD is 10. So for 26, our value of z is minus 2.4. So area of normal distribution are often represented by the standard normal distribution, and this z column contains the values, and this, the area below z contains the area. Now here we find z is equal to minus 2.40, which represent a value of 2.40 standard deviation below the mean or on the left hand side of the mean. Because as we see, when we convert the distribution into standard normal distribution, this value here it is a 50, but it becomes 0. Okay, this is minus 1, minus 2, minus 3, 3 sigma, plus 1, plus 2, plus 3, mu plus 1 sigma, plus 2 sigma, mu plus 3 sigma. So now the original values 50, 60 will gone, and 0 or mu, which becomes 0 now because we converted into 0, where a distribution with mean 0 and standard deviation 1. So this becomes 0, minus 1, minus 2, minus 3, and so on. So now we have to calculate probability less than 26. Okay, here we have to consider the probability normal mean below 26. Below 26. Below 26 means less than 26. Now keep in mind, so in normal distribution, the middle value, standard normal distribution, this middle value is 0. And minus 2.4 is somewhere here between 2 to 3 on the left hand side, and we need a area less than 26. Now that is area minus 2.4, that is left hand side from that 2.4. So from this table the area is given as 0.0082. So the probability that a value is less than 26, its probability is 0.0082. So this is the continuous distribution, and we have find the continuous values. But suppose any discrete value is given, and if we want to find a probability of discrete value, now keep in mind that as this is continuous distribution, the probability of any specific point is 0. Suppose we cannot find the probability at point 8, or uh, probability for 8 head or 10 head or 15 head. Why? Because this is continuous distribution. It gives us range. So to overcome this problem, what we have done, we have, suppose we want to find that outcome is 8 head, then we find the range 7.5 to 8.5, then subtract 7.5 from 8.5, and that range will give us the area or the probability of getting 8 heads. Similarly, for any given 2 points, let us say 8 to 10, we have to calculate from 7.5 to 2.5. So again, the middle value will be 0. For 10.5, we have to calculate Z1. For 7.5, we have to calculate Z2. And subtract the value. Z2 minus Z1 will give us the area under the normal curve. So friends, today we have seen how to find the probability of continuous and discrete random variables using tables and statistical calculators. Hope you enjoyed. Thank you.